When we talk about superheat, we're talking about the temperature of a refrigerant when it's raised above its saturation temperature at a specific pressure. This will vary per refrigerant type and also for each application. Controlling it ensures we have sufficient heat absorption within the evaporator to actually absorb that heat that we need to produce our cooling effect, whilst preventing liquid refrigerant or anything which hasn't boiled off yet from reaching the compressor. So it protects our system at the trade-off of slightly less efficiency by not having a completely flooded evaporator. This boiling off in the evaporator is what we call useful superheat. So when we talked about pipe sizing before, we raised up the term of useful superheat versus non-useful superheat. Useful superheat is anything inside the evaporator which boils off that refrigerant past its saturation temperature. Non-useful superheat would be anything which then gets absorbed between the outlet of the evaporator and the compressor. Too much of that will cause the compressor to be effectively have insufficient cooling going to it, which will result in high discharge temperatures and affect the properties of the oil and refrigerant in the system. That's calculated as the difference between that refrigerant's actual measured temperature, which we could detect with a probe or a sensor bolted onto the pipe, and then that saturated temperature at the same pressure.